Good evening, ladies and gentlemen. On behalf of the chairman of the Oxford Educational Institutions, management, principal, faculty members of the Department of MBA, the Oxford College of Engineering, it gives me immense pleasure in welcoming you all to the 5th day of the 6-day online AICTE ATAL FDP program on next-gen management, applications of artificial intelligence, and data analytics in business strategy. I take this opportunity to welcome our resource person for today's first session, Mr. Sachin Renge from MathWorld. With over 25 years of global experience, he is a technology and product delivery leader, passionate about building high-performing teams and driving innovation at scale. He is an alumnus from IIM Kozhikode, and he has completed his bachelor's in instrumentation and MTech from VLSI design. So a deadly combination of engineering and management. So his job expertise includes convergence of technology and business, aligning strategy with execution to create sustainable growth. From spearheading digital transformation and new product introductions in global market to optimizing product processes that improve productivity by over 40%, and a focus on delivering tangible value for customers and stakeholders. His career journey spans leading organizations like Autoliv, Infosys, and Bosch before joining MathWorld. He has engineered teams that has grown from 30 to 200 plus, launched multiple product lines, and delivered complex programs exceeding $15 million in value across SaaS, AI/ML, data engineering, embedded systems, and VLSI. He leads end-to-end deliveries and solutions across diverse technology domains, combining deep expertise in both software and hardware systems. With expertise across both software and hardware ecosystems, his technical domains include embedded system, VLSI, C, .NET, Java, cloud technologies, automotive and ADAS, radar, vision, braking, airbags, AI and machine learning, industrial automation, data science, data labeling, MATLAB products, and integrations. He is also a certified PMP practitioner, bringing expertise in Agile, Scrum, Waterfall, and hybrid technologies, ensuring governance, quality, and delivery excellence. A very warm welcome to you, sir. I now request Mr. Sachin to speak and enlighten us on bringing the notion of quantification and structure into industry knowledge. So over to you.
Yeah. Thank you, ma'am. Can you please confirm me if I'm audible?
Yes, sir, you're audible, and I've made you the co-host, so you can use the screen, everything. You're audible and clear.
Sure. Yes, thank you. So in between, I may keep my video off so that my bandwidth can be utilized properly. Okay. So before start, I would like to understand the audience. So please type from which city you are. I would like to understand that.
The audience is a combination of faculty members from management, MBA, and some of them from the engineering background, but many of them are management. And
management faculty, okay.
Management.
Okay, perfect. And all are from Bangalore?
No, it is from all over India, sir.
Okay, perfect. Okay.
Maybe because of some technical glitch, they would be floating, but right from Kashmir down south to Tamil Nadu, we are having people. People from Mumbai also are there. but some technical glitch, it would be floating.
Okay, great. Okay, thank you. So I would like to start. I will share my screen. Please confirm me. Can you see my screen?
Yes, sir. Visible, sir.
Yes.
Okay, great. So thanks for the introduction. Quickly, I will introduce myself, followed by some of the basic concept of AI, ML, and how it's being used in the industry, and then how can be. So, as ma'am have explained that I have done my masters, I will keep my video off. I'll keep my video off for the bandwidth purpose. So, I have done my degree into engineering, the master degree into VLSI design, which is the advanced electronics. After that, I have done my business management from IIM Kozhikode. Some of the technical and non-technical trainings I have done, and I have good orientation and good awareness about the CMM process, which is being used in the industry. So these processes are used for the quality improvement and predictability purpose. Totally close to more than 24 years of experience. Out of that, 10 years experience I have done hands-on on the software development, and 15 years into project management, program management, portfolio, and the delivery management. In this entire year, I have worked on industrial automation, automotive domain, and I got opportunity to work with client and travel in multiple countries of Europe, America, and Asia. So, as a part of program management, what we do, so when we work on the program management, we work on certain products, and those products will be developed by using certain technologies. And on the below V, you can see left-hand side of the V. Left-hand side indicates the development and multiple stages of development. Right-hand side it indicates the multiple stages of the validation. So code validation, hardware validation, or system validation. And when we work with management, we have multiple roles to play. Here is short summary of the role. Strategic alignment. We align with the organization's long-term and develop the core work on product to meet the long-term goal of the organization. As part of long-term organization goal, we break those goals into short-term achievable, put down that as a roadmap, planning, tracking, and ensuring those metrics are being developed to get the targeted strategic plan executed. Then stakeholder management, risk management, resource management, and the governance and the compliances are some part. So, and mainly we focus on the continuous improvements. This is my small summary of journey. Most of my experience is into product-based company, and some of the experiences in service, where I develop the electronics embedded product or software product for multiple domains such as automotive, industrial automation, oil and gas. So in this duration, I got the opportunity to scale up my team, and then this is the scaled agile, which is the complex process. And these are few of the products where I work with. So you must have heard about the driverless car. So as a part of driverless car, I work with multiple OEMs and develop multiple algorithms. Let's say lane change assist. I'll put down the pointer here. Here you can see this is my car. On in front of my car, there is another car. So it's detecting, machine learning algorithms are developed to detect that there is a car ahead of me. Then it will take its own decision whether I should take left or right, and then it will check its blind spot also. Whether if there is a vehicle on the blind spot or left or right, and then it will take decision which side to turn. These are the lane changing algorithm. Blind spot. So just near the blind spot, there are some vehicles which is not detected in the mirror, but there could be some condition or the vehicle around that, so those can be detected. Multiple algorithms, those are being used in the machine learning and autonomous driving. Those are being used. Previously, I developed the airbags for multiple OEMs. So recently, we are working on V2X technology. So, what is the V2X technology? So, going forward, there may be chances that your car will communicate with vehicle to vehicle, vehicle to infrastructure, vehicle to pedestrian, so and vehicle to cloud. So, data will be given to cloud. So, the vehicle will communicate with other vehicle, which will avoid dangerous situations. So those we are working on the prototype. So in that also we are using AI extensively. So these are the driverless car, autonomous driverless car, the different levels. In India presently we have this level present. Mahindra XUV 700 or recently Tata have launched some of the vehicle. So those vehicles have autonomous level 2. You must have heard about some of the autonomous car from Tesla. Those are level 3 car. We are working on level 4 and level 5 now. So what's the difference between this? So on the layman term, I'll say that firstly, we are trying to say that leg should be off. So that means no braking required, no acceleration required, braking is off. Yeah, that's kind of level 2. Level 3 is you don't have to keep the hands. You can remove your hands from the steering. That is some kind of automatic driving, but passenger should be still sitting there. Sorry, driver should still be behind the wheel. Those are the level 3. Level 4 means your eyes off. Driver don't require to pay attention. And then in that case, whenever there is a hazardous condition, car will park on safe side and then it will ask driver to take a control. And level 5, that means mind off. You don't have to worry. You can sleep, put down your destination, car will take you over there. So these are the 5 level we are working. So at this moment, we are in the stage of development, level 4. These are the multiple systems being used. I'll skip this moment because our intention is not to understand that. So we have gone through the industrial revolution. We already studied that, but luckily we have got the exposure and we are going through the next stage of industrial revolution, which is industrial revolution 5, which is the AI. AI is going to change a lot of things going forward, and AI is being used by multiple people, multiple domain, multiple designated people. They are using this AI. So there is a myth that AI is going to replace the job or AI is going to do certain things. So basically, AI is going to empower you to take the better decision. AI is not going to make certain AI is not going to check your jobs unless and until it's going to be easy, but mainly AI is going to help you. Let's say as a part of professor, AI is going to help you to somebody is typing or writing on the screen? Okay. So AI is going to help you to take the better decision, analyze the data, and then predict the data. So what is the AI? So AI is going to make the machine to learn from its experience and perform like a human. So it's going to perform the human task and make human life easy. So it's assistant at this moment. It's assistance to the human. Going forward, we don't know it's going to replace human. What level is going to replace, we don't know. But at this moment, we are targeting that it should help human to perform his task. Now, what kind of AI can be used? So left hand side, you can see there is lot of numbers, charts, text, images, sound. At this moment, those could be the input to the my AI system. And based on that AI, it will take decision, what action to be performed. Let's say robot will come to you, a car will decide whether to apply brake or not. That's the decision making is going to make. Is going to predict the things that okay, what could be the weather outside after 1 month, or what could be the market forecast after 1 month, that kind of prediction. So, and then it will generate the data which is required for the human based on the given raw data. Let's take this example, artificial intelligence. So, as a part of artificial intelligence, on the top right, it's going to check that, hey, what is the color? How is the color? Then how is the texture, or how is the format of the given material? Is it dry or wet? What is the percentage of moisture? Then lot of size, color, lot of information they're going to give. So how they give this? So they use certain algorithm. We call them as a training. So we train them, we tell them that this is the red color, this is the blue color, and then computer don't have its own uh, computer don't recognize the color. It doesn't recognize it. Computer doesn't have the intelligence like human. But we are trying to give that intelligence to the computer by training them. So how we do? We provide lot of data to them. It's not one data. Let's say the person computer should identify me as a human. So and then human should be predicted. So lot of humans photograph will be given to computer in standing condition, running condition, swimming condition, sitting on the chair. So lot of photo from the different directions, those will be provided to, and those will be called as the raw data. Those will be provided to them. Then those will be processed and computer will start its learning that hey, these are the different, and those are called label data. I'm telling them that hey, this is human. I'm uploading 1,000, 1 lakh, 1 million, those many photographs I'm uploading, and I'm telling these are the different humans. So based on the raw data, my system is learning. So I can give them that rupee note. This is 10 rupee note, this 50 rupees, 100 rupees note. I can give them photograph, and then different from different angle, different different size, and then it start processing and learning. Once it's learned, then I will apply the machine learning model on that. Machine learning model, why? For the prediction. Firstly, I ask them that I train them. Okay. I train them that this is the human and this is the note. This is the currency, human and currency. Like that, I train them. Next, I will apply the model, different model. Those will be applied by the machine learning engineer. And then they will tell that then prediction, decision making. That hey, next thing, I apply 100 rupee note, it will show me decision that hey, this is the 100 rupee note. or if I apply the cat, then it will say that no, it's not of any of the category, it's something different, which is I'm not trained for. So that kind of feedback is given. So all this system is done by the engineers, technical people. So how they do inside, when I told you I'm going to give the currency, 10 rupees currency. So every currency photo from the different angle, different density, different size. So, but overall, if we put the algorithm, a lot of mathematics is involved. So 10 rupees note will go to one area. It will not be exactly one dot. Because of the variation, photo angle, or some size, it will go to dot, let's say 10 rupee dot, 100 rupees, then the 500, and then this is the human. Okay. Then what we do, we tell them the algorithm, we create the algorithm in software, we group this. That okay, this circle is for 10 rupees, this circle is for 50, this circle is for 100, and this is the human. Now, next time when I provide once again one more photo, it check on the background. It doesn't take as a photo. Inside it calculates as the mathematical formula, and based on the mathematical formula, it check whether it falls in this category, this or this. If it is any of this category, it will detect that, okay, it's human. But you can see that now this is yellow color over here, this is neither here, neither here. Or this is yellow color, this one, neither here or neither here. That means, in that case, it may say that, hey, it may go here also or here also. It depends on the algorithm. You can't say that it will give correct answer. That's why we say that machine learning doesn't give the 100% output or the guarantee at this moment. It gives more the data you train. If I train more data, and if I say draw the circle like this, then it give me more. But it has its own complexity to train more and fine tune more. But as of now, this is the logic we apply that mathematically background, this kind of things which is called as clustering, and we do the clustering, and that's how we train our algorithm. And then whenever new algorithm comes, new image come, we check with the existing clustering where it fall, and then it gives me, hey, this is the decision making they do, and then it gives me feedback in which category it goes. Now, AI, when we talk AI, what is the AI? We know that AI is the machine making the intelligence like human. But under AI, there are multiple technologies, limit machine learning, deep learning, generative AI, but not limited to this. There are multiple technologies, and then those are being used. So those are being used. Let's say learning is part of machine learning, and machine learning is part of artificial intelligence. So that's how it's connected. So now you can see these are the two technical things, but I'll not go too technical here. But artificial intelligence, LLP, large language processing, you must have used Copilot, ChatGPT. Those are the LLP. Neural network, those are the inside of machine learning, deep learning. Those are the prediction models. And computer vision, that means camera-based system. When we integrate those multiple systems, create like computer detect, take the photograph, give it to the system, then it applies the machine learning, it goes to the neural network, and then it gives the AI output. So it's an interconnect. There is no particular sequence for that. It purely depends on the application. So here you can see on the base there is a data. Always there is a data in the digital format. Whenever you're giving your text, songs, images, video, those are always in the form of binary data. On those data, multiple algorithms are being used: machine learning, deep learning, neural network, computer vision, NLP, speech recognition, and that's how we call that it becomes the AI. not necessary that all need to be applied. It can apply any of the thing or all of the thing. It depends on the situation. So this is what I told, that artificial intelligence contains once again more complex system. Machine learning have its own algorithms. Neural network, deep learning have its own algorithm. That's how system start becoming complex. But on the higher level, when we have the data, we go with data. There could be structured data, non-structured data, tabular data, image data, multiple data. Then it goes and gives the information as a visual information. Then from the visual information, it gives the insight on the context, how the visual information is going to interpret. Then it creates design and it helps for the taking decision. I will take you through one small slide if I have open. Yeah. Now, if you see here, this is the raw data. You can see this is the Excel imported by. This is the Excel imported in any of the tool. This is the raw data. Now, if I give you this list, you will not be able to take any decision, or you don't know what is meaning of this raw data. But when I plot this data, it gives me that, hey, how many tasks are in to-do condition, how many tasks are in progress, how many tasks are in done state, what is the percentage distribution for that, what is the task gone in the sprint 1, how many are in sprint 2, how many are the next sprint, and then which activities are what level completion. Now, when it was the raw data, will you be able to compute this? So no, answer is no. It's very difficult. You need to do this manually. You will not, based on this raw data, you will not be able to take any business decision. But when you are putting this data in measurable and countable format, this is called as data analysis. So now I am analyzing the data, putting the data into measurement format. That okay, now I know based on the raw data how many activities are closed, how many activities are in progress, how many activities are in done state. So based on now, I know that okay. So this is called as data analysis. Okay, so that's how data, when we have the raw data, it could be Excel format data. You are going to visualize that data as I showed you in the earlier context, and then based on that, you are going to take the decision. Now, instead of the random decision, going forward, your decision will be data-driven decision with certain insights. So now you have the data, you have the insight, and you are going to take action. So whenever any person asks you, or you will be the manager, or you will be the going forward action decision maker. So you need to understand insight for that. What decision you are going to take. Let's take example. You're traveling. You have option of by taking the car or going by the flight. So now you will take insight and you will collect the data. So let's say I'm traveling from Chennai to Bangalore. Now it's a 5 hours drive by car and 4 hours close together from door to door, 4 to 5 hours once again by flight also. In that case, what is the better decision for me? I will collect the data, I will take insight, and I will take the action. Let's take example. I have two proposals. A proposal, B proposal. There are certain risks in A proposal. There are certain financial data, my budget. So I will take the decision based on the data. What is my budget? What is the timeline? What is the risk? I'm going to analyze based on the data, take the insight, and take action based on that. So earlier I explained you about the AI. Now I'm going to, these are the little theoretical concept. Please bear with me. Now I'm going to explain you data science. So data science means you are taking the raw data, as I showed you in the plot, showing the data, putting the data, and putting the machine learning algorithm on that and predicting the future. Those are called data science. Data science, machine learning are part of the AI. So this is the life cycle of the data science. But data science itself is becoming very popular in India. There are a lot of jobs or a lot of opportunity around the data science nowadays. So when you are taking the data, Excel data or some kind of data, so sorry, you need to first understand your data is neat, clean. If there is unwanted data, is there any random data? You need to identify those data. So let's take example now. Marks, when anybody is entering marks 1 to 100, some candidates mark are missing. By mistake, someone instead of 100, someone entered 1000. Then we check those possibility that, hey, is this invalid marks, or is it like something wrong in the given mark, or anything blank, or wrong entry has been done. We check that. We take the data, we transform the data, then based on that, we do the data analysis. We analyze the data. As I showed you here, we analyze the data in a different format over here. Okay, now this is like whatever happened. I'm doing postmortem of that. How, based on my historical data, how many tasks, how it was performed, and those called as data modeling. Now, on that, I'm going to put on the machine learning algorithm. I'm going to predict the thing that last time my team have performed these many things. Let's say any production, vehicle production, they produce with 100 people manpower, they produce 1000 vehicle. So now they want to produce 2000 vehicle. How many manpower is required? So what salary is required? How many budget is required? How many more investments are required? Those will be applied by taking the data and applying the machine learning. That's how this is the data science apply. And then it will go to the management to take better decisions. So this is the data science. So I mentioned raw data, processing the data, and giving the information to you to take the data-driven decisions. Now, there could be structured data, non-unstructured data, semi-structured data. Everybody must have used Excel. So those are called as structured data. We use the image, videos, those are unstructured data. And there are some of the HTML file or JSON file, those are being used in the software industry. Those are semi-structured data. Now, how is going AI? How is going to change? AI is almost changing all the streams of the engineering. Water engineering stream is going to be impacted. Then data science, artificial intelligence, go impacting all the industries. It could be healthcare industry, aviation, finance, logistic, agri, social science, automotive, and retail. I'm going to give you the example how is going to impact, but these are few things, but not limited to this. Is going to impact majority of the thing. Is going to impact majority jobs also. Either your job, education job, marketing job, HR job, transport job, sales job, e-commerce, manufacturing, social media is going to impact. Impact doesn't mean that is going to take your job. Is going to impact means going forward. In earlier days, certain task was, certain code was getting written in 10 days. Going forward, it will be written in 5 days. You salesperson, something opportunity, he was doing lot of study. Now that study will be done within few hours. Transportation, as I mentioned, that artificial intelligence driver is not no more required. Education, marking, automatic marking, grading systems, lot of chatbots. Those are education is going to be impacted. I visited one of the school, and in that school, I saw that there were two teachers in each school. First teacher was human, and second teacher was robot. So that means there was assistance of robot already, assistance of the robot implemented in the school. So it's impacted to that industry. So it's going to impact all the industry. Majority of the participant doesn't require to learn the AI here, but you don't. AI doesn't mean that you should write the AI code. No, you should learn how do you make use of the AI. That is enough for most of the people. But still, if anybody is really willing to learn, he can learn Python, then followed by data science, followed by machine learning, deep learning, and then the AI. But AI is changing. We are too early stage of the AI. We are not in the mid journey. We are in the early stage of the AI. So every year AI is changing rapidly. A lot of changes are happening. So when you are learning stage, let's say you learn the Python, there are the job associated in industry for each phase. You learn Python, you are the Python software developer. You run the data science, that means you are the higher level now. You know the data analysis, plus you know the Python. So you are the data analyst. Salary will be higher. Now, next is machine learning engineer, data scientist. That means they know these two, plus they know one more level up. So their salaries are high. Those are machine learning scientists. Deep learning, they know all the below, plus they are one more level above. And AI architect, they need to take decision at each and every level. So depending on the knowledge, salaries will be impacted. And then one more thing, everybody should not know how to develop it. Important thing is how to make use of that. These are some of the tools that we use. And when we use the AI or machine learning, we should be very strong in mathematics, computer science, and business. And then these three things come together. Let's say computer science, that means I should be very good in language. Computer science is nothing but these are the language. Person should be aware, person should completely aware about what domain they are, what kind of problem they are solving. So data science person should have combination of all the things. He should have the domain expertise, computer expertise, and mathematics experts. If you say that, hey, I don't have all this, I'm worried, you have different levels. You can be at the first two levels. These are the different level of tools that we use at the different levels. These are the different levels of jobs available for engineers. But on the higher side, data engineering, data analysis, machine learning scientists, data scientists, these are the most popular job and available job in India at this moment. Now, when we are processing the data, we always in the industry we always say the problem, what define your problem, what kind of problem you're going to solve with AI or the data science, then collect the data, clean data, analyze the data, visualize, and the make decision. This is the flow. This is the same thing I mentioned. It's a data, you're going to fix the data, lot of stages are there to clean the data. Then in this stage, you are going to label those data that you have given dog, it will show it's a dog. labeling that kind of data, then you are going to apply the machine learning, modeling, and that's how prediction. So these are like cycle, it's continuous cycle. You train the data, your machine learning algorithm will be more accurate. Based on that, it will generate more accurate data. So more use, more data, more accuracy. I will example over here now. Here, computer doesn't know this is the star, this is the rectangle, this is the triangle, this is the square, this is circle. It doesn't know anything. Now, what we done, we have mentioned, we provide the label data, as we mentioned. We have done clean the data. We have clean shapes now. Okay, we have the clean. Now we are going to label the data. That means I told them that okay, this is the star. I labeled it. This is a rectangle. I labeled it. This is a triangle. I labeled it. Okay. Or I may label based on the color also. That okay, this is a yellow color. This is blue color. This is a red color. Whatever I want, I can do based on that. But at this moment, I'm interested in the shapes. So I labeled those data for different shapes. Now, whatever data I have given, I label those data, I give those data for validation and then data preparation purpose. I given it to the computer now. It's going, taking data. As I showed you, one of the slide is taking the clustering. Clustering means this one. This is the clustering. When I give triangle, rectangle, hexagon, it goes in different area based on the algorithms. So those are the clusterings. So now label data goes for the clustering and it goes for the model training. Now what I'm doing, I'm teaching my computer that hey, I given 1,000 sample of star by saying, hey, this is the star, this is star, 1,000 sample, not limited to 1,000. You can give 1,000,000, 1,000,000,000, whatever sample you want. More sample, more accurate data, more memory, more processing. So those are the accuracy will be higher, but there is the cost for those training. So I trained those for this. Now what happened? Now I have trained my model. Now I need to evaluate the model. I need to check. Then what I will do? Now less training is finished. Now I'm going to test it. Now let's take I given this as a sample. And I remove the star now. I remove this label. Training is already completed. I remove this label and I simply given any of these randomly. I'll give random any of these shape. I will tell them it will check in the given cluster. If it is close to given cluster, it will say, hey, it is star, it's circle, or it's a triangle. Based on that, it's now started predicting. I labeled the data, I trained my model, then I started predicting it. So that's how it's a model evaluation, model validation, and deploy means available for last user to use it. So that's how I created my model. Inside that, how decision making is happening. Let's say if I say given one square, it will check. It could be any hierarchy. It will check any of these. Let's say we have 1, 2, 3, 4, 5. 5 shapes. I give circle over here. On the first one, it will check whether it's a square or is it a triangle. It will say no, is it square or no. Then if it is say no, it's not square, then it will go okay. If it is not square, then is it a hexagon or is it a circle? Then it will come okay, it's a circle. That means it goes here. That means this path. Similarly, it will go over here. And when I given only one shape, either of any one will come true. And that's how it start predicting things. So these are written by engineers. Now, this is my label data. I have camel, I have elephant. I have labeled the data. I have the trained algorithm. I label them. I train those algorithms. Now, what I done now, my algorithm is already trained. Now I'm going to tell them that, hey, now you are already trained. You are good enough to help me now. Okay, then what is this cow? But computer doesn't know. It should help other computer to predict. Or when your camera is on the road, there are multiple cameras installed. We tell the camera, we train those camera by using our cow, animal, and then we tell them that okay, any person a car is moving beyond the certain speed, take the photograph. But if any animal is moving beyond certain limit, don't take the photograph. We tell them animal detection or human detection. So now it's going to take. Okay, this is the thing. I have three photos now. You tell me which sheep. So it goes in this cycle now. Okay, it will check. Okay, it's cow. Is it cow? It will say yes or no. If it is yes, then it will go here. Okay, that way it shows, and then output will be given. Okay, don't think that human by eyes can detect that it's cow, computer can detect. No, if you just simply show computer that show me, you take photograph and tell them that show me is it cow or not, it will not detect. You need to train them. So that kind of this is one of the simple example. Now I'm going to make it little complex. Now this example is being used in the industry, fruit industry. Okay, so to detect whether fruit is good or it's not, it's rotten condition. You can see these are different fruit. It's predicting. I'm giving the fruit over here. I already have trained those algorithm. I mentioned them that this is the good fruit, this is the rotten fruit. So based on that, it already give me that okay, this is the rotten one and it's good and whatever fruit it is. So that kind of so it's going those whatever I told you theoretically is going in the practical industries now. So just to warm up, AI. When AI, that means it's mimicking the human intelligence. We are asking machines to learn from the data and develop intelligence like human. Data analysis means draw the insight from the raw data and help me to take the supportive decision or predict the future. Those are two different parts. You may learn what is the data analysis, what is the AI. Altogether, it's under the AI umbrella. So, on the business strategy application, going forward is going to impact the customer segmentation, supply chain. You are the MBA people, you must have heard about that. These are the different departments is going to impact, and is going to impact multiple frameworks also. Some of the use case, so Tesla, Amazon, healthcare, some of the example which I'm going to in detail. Now, what I told you that AI, that means do you need to learn the AI? Do you need to learn and master the machine learning? No. You should know how to use the AI. Chatbot, there are multiple chatbots are available. Large level modeling, let's say Llama, generative AI, prediction model. So there are multiple generative AIs are there. You should start using the generative AI. Okay, so generative AI internally use all these things, computer vision, recommendation system, LLM, and the predictive model. Let's take example of ChatGPT, Copilot. There are many photo creation, video creation, or PPT creation. Those are generative AI. You should start knowing those generative AI and start learning those. Now, in the industry wise, is going to impact. Now, I told you theoretical concept. Now, in the industry, how AI is being used and how those are changing in the real world, that I'm going to tell, is going to change all the industry, including the education industry and most of the industry, agriculture industry, logistic, e-commerce. I have given few name here, but not limited only to this name. There are most of the industries going to be impacted because of AI. Let's start with the healthcare now. What is the real example of the healthcare? Let's say when we take the MRI or when we take the any image, X-ray image, we know that we do the training. We have trained our algorithm. So similarly, we took lot of raw data. We took lot of X-ray. We took lot of MRIs of good person and the infected person. And then we told them, we trained those machine learning algorithm, and then now prediction is in the prediction stage now. It's going to predict whether human brain or healthcare system is good or not good, or if it has certain problem, or the system is really good enough, not required to do anything. So it's already started diagnosing the things. Okay. So concept once again same. Going forward is going to assist the doctor to take the decision. Presently, doctor are looking towards your MRI and then they are taking the decision what happened. Some experts are required. Going forward, expert is going to help the expert by saying that, hey, there is some operation of the nerve. I see that this is the possibility. You please validate this. He's going to validate it. Decision making will be doctor. He's going to give the supportive data to the doctor. So that's how healthcare industry already started using it. In the healthcare, it started in the drugs also. AI, identification, discovery, optimization, the testing, clinical trial, and regulation. Long phase. It's a 2 years, 5 year, multiple years phase. Is going to optimize those phase. They are going to mix the chemical and is going to change, predict molecular output, and by saying that it's a drug discovery. Those are the things which are being used. So then predictive analysis of patient. So patient's data is already fed in the system. Then when you're generating your reports and when you're putting your diagnostic system, it will detect that, hey, these are the type of illness, possibility of illness. And in US, many of the hospital I observed, they are doing the data analysis, observing the patient's data remotely. You could be at Singapore or you could be at the remote location, but data is being transferred to the doctor on the need basis, and doctor do the analysis on remotely. That's how it's being used. And there are multiple chatbots also available nowadays. You put your query, and it will say that, hey, last time you took this medicine, now next recommendation is this one. It will assist you that way. Next example is, I'm trying to cut it short because of the time. So finance industry next. So we know that finance is the most sensitive industry. Everybody has the bank account. Those bank account are in the bank. We care for the bank. We know that we should not give any OTP to any person. Multiple SMS come by saying that your vehicle challan is due. Click on this link. Then if you click on that link, your mobile can be compromised. So similarly, a lot of fraudulent cases are there. So how to detect those cases? How to onboard the people easily by using KYC? How I can give the 24/7 support? How I can protect your money? How I can give you flexibility to access your money from any point? How fraudulent detection can be done? How it can be prevented from the hackers? Those are all are being used in the industry. Recently, I developed one project. I was part of one of the project. So I developed one algorithm. So many times I observed that people take the KYC, alter their name. Some people are doing and taking the fake Aadhaar card or altering the name on the digital copy of the Aadhaar card and giving it. So we created the algorithm to check whether that scan copy or that photo is genuine or not genuine. If it is not genuine, it will tell the system that no, it's not genuine. So that kind of fraudulence avoidance also we are doing. Many of us know the next application of this AI is algo trading. Algo trading is not safe. I am not recommending it. This is not my recommendation. But what I can see that AI can be used to understand the market trend. Many of you might be closely watching the market, stock markets. So if you give to the co-pilot chat GPT that, hey, this is the market trend of last 6 months, help me to understand the data, it will show you how is the pattern and it will help you to predict the price. But make sure algo trading, I am not recommending it and I'm not against of it also. So market is not doesn't go as per the any defined algorithm. It is volatile. It purely depend upon people's money. More foreign investors start investing, market will go up. It start pulling it, market will go down. In that case, your algorithm will not play any useful role over here. But it will help you to predict things. In the banking industry, another application is your KYC. It will check your score, it will check your history, and it will start predicting. And then, if your score is good, it will give you some kind of benefit. So, that also things are going on. And on the finance side, there are some personalized investment tips, your personalized need or personalized financial advisory can be provided. So yes, those are good things, but it should be personalized. You need to give lot of data to them, but it should be really trusted source. Next one is e-commerce. Most of you might have seen that if you search something on Google, let's say shoes, you will start getting the shoes pop up always. If you see some watch, you will always, or wherever you will go, you will see that watch is being displayed. So those are the recommendation engine. On the backside, we know system know what you search. Most of the people might have you heard about this or experienced this. When you search, you start giving you recommendation that you purchase, let's say, watch. Then there will be recommendation that hey, you have one watch now, start purchasing the shoes now, or you can go for the another item, which most of the people bought together. So that kind of recommendation, or within your budget, based on your shopping pattern, based on the season, it the system will start recommending you. That means AI is going to help you going forward to make your decisions easy. Pricing, it's in the initially there was static pricing. Going forward, it will show that hey, pricing, let's say winter, that means winter demand, winter wear, things are more. It will check how is the produce of all over the clothes, and it will say that produce is high, demand is high, your profit or your margin will also be high. So it will predict the demand and it will propose you the pricing also. What pricing? That means it will help you to increase your profitability also. Now, this is on the retail side. Let's say I am here now. This is my history. I have given him historical demand. What is my demand over the year? So let's say here demand increase, here demand fall. Once again, demand increase, certain season, demand fall. So I'm here now. I'm asking him next year, what stock shall I maintain? Then he's saying, okay, you can't maintain the same stock. Sorry. You can't maintain the same stock. Your demand is going to increase. So it will go to this one. Though you are 525 this year, next year prediction is 600. Then I say, okay, in this time period, it says to me, no, in this time period, you don't have to really maintain the stock. It will be wastage and lot of godown or warehouse stock prices will be saved. Maintain the low stock over here. But what is the minimum quantity? It's suggesting me. So it's a prediction. So that's how it's helping me to maintain the stock, do the right investment, use my warehouse effectively. One of the example I would like to explain you the decathlon. I don't know how many of you have visited the decathlon, but in the decathlon, when you do the purchasing, by the way, decathlon is the sports equipment shop. It's available in majority of the cities. When you purchase any sports equipment or sports shop, you go to the counter. You can make the billing and then you can make the payment. That is your traditional way. But there is a cart over there. You just go ahead, put in the cart what you purchase. It will detect automatically what item you purchase. It will show on the screen how many quantity and what is the price. And then it will ask you to pay the bill based on your preferred media. That means it made your job easy. You don't have to stand in the queue. You can go ahead, start shopping, and then go ahead, make your own payment and make your life easy. Now, next one is manufacturing industry. So we know that most of the industry are being manufacturing industry. Lot of labor is intensive activity. Lot of machineries are there. Lot of oil, grease, belts, lot of gears, lot of things are required, and then every machinery have its own life cycle. Its component have its own life cycle. Then when maintenance is required, or it should not say that when I'm doing my production, I have the order commitment, my machine stop. It should not happen. Then that's how predictive maintenance will come in the picture. It will show me that he last my machine was this is the timeline of the machine, and then you are supposed to change this part every this time period. This part is not changed, now time to change. So it's giving me early warning. The way when we drive a car, we drive bike, you know that when yearly once service has to be done, is a predictive maintenance in our mind. So similarly, our vehicle is one component for us. We can go in, but when it goes to any engine have lakhs of components. Then it will give you that okay, these many components need to be changed. These many components need to be replaced, changed, or maintained, or what activity has to be done. This kind of dashboard will be provided to the control engineer or maintenance engineer, and then maintenance engineer will go make the necessary changes and make this manufacturing smooth. Okay, quality control. Going forward, most of the industries are using computer camera. You can see camera over here. So those are called as computer vision. So camera detects the photo, it checks, gives the photo to the backend algorithm. It says whether it's required based on my trained data. Is it a real required product or is it unwanted product here? It's checking the quality. Is it a good fit product or is it some kind of damage? It's help. It's help to the quality control also. Let's suppose that okay, it's not able to make the decision, then it will come to human to analyze it and make the decision. Supply chain management, when we know that from warehouse to giving, let's say, Amazon, from the warehouse to shipping it to you, that entire ecosystem is going to be replaced or updated based on the AI. Many places already, customer care is already updated by chatbot, but many of the systems are being getting updated. This is transportation and logistic. Logistic and transportation, they started using AI long back. You know that vehicles are moving over here. So in India also, we have started developing good infrastructure now. So in our infrastructure, we have proper lane marking. Vehicle required the lane to get detected so that vehicle will stay within its own lane. Okay. So there are multiple features in the car. So it will say that, okay, if I say adaptive cruise control, my vehicle speed is 100. If my vehicle will keep moving in the same direction. If we detect any obstacle, an obstacle rate is below 100, if it is, let's say, 80, for example, automatically brake will be applied by my car. It is because of the AI. It detects. When that next obstacle move to the next lane, then it will once again pick up 100 speed, whatever I stored in the memory, and then keep moving. Okay. It will keep moving till the time it again detect the next obstacle. How it detect obstacle? It can be human, it can be any animal, it can be any stone, or it can be any tree, anything. There are some algorithms, labeled algorithms, those are being already installed over here. So those are called a detection, a detection algorithm. So it detects what is the next. If you go and check Google Tesla video, you will see that Tesla detects that what is there. Although sometimes it detects the wrong thing, which is okay. We are improvising those algorithms, but it started detecting the thing. Next thing is it will take the decision whether to take the left turn or the right turn. It will take the decision also. And based on the movement, it will take left or right turn and then keep moving. That means going forward, car is going to start, when they start using AI in the autonomous car, is going to drive its own. You go sleep in the car, put down the destination, it will manage the traffic, it will detect the pothole, it will detect the red light signals, it will detect the police, it will check the warning of the police, it will make the decision whether to halt or not to halt, whether police is asking to stop. All the decisions are being will be taken by this vehicle. So as I mentioned, in the autonomous car, going forward, it will take its own decision. You need to put the map on. The car will not know which area to go. So you need to put down in the map that in which area you want to go. Then it will start communicating over the multiple protocol. It will start communicating with other vehicle. It will start communicating. It will start sending your location to other vehicle. It will detect vehicle. You can see in these boxes, they have already detected the vehicle, and then it take the decision to move, and it will communicate with the other vehicles also. Yeah, this is another example of how vehicles will be communicating. So it will say that, okay, what is my distance from you? It's saying, okay, your and my distance is this much. Okay, your and my distance is this. This is the distance. Okay, and then this is getting communicated to this vehicle by saying there is a red light ahead of me. Then it's broadcasting that to this vehicle and this vehicle, adjacent vehicle. There is some signal certain meter ahead of me. Then this vehicle will broadcast to all the nearest vehicle by saying, hey, there is a two vehicle ahead of me and there is some signal. Be alert. I am going to stop now. So that way, he's communicating that, okay, don't apply the brake immediately. I am this much close to you. You apply the soft brake. That's how this vehicle will keep communicating. Vehicle will keep communicate. It will communicate with humans also, as well as on the infrastructures also. Okay. So going forward, your logistics will also autonomous vehicle will be given. So you have some luggage. You just put down the luggage in your given vehicle. You put down the destination. It will come to the given destination. It really doesn't require the human presence to drive those vehicles. These are one of the different. So AI is going to use the different level of cars also. It will say that okay, it's a bike, it's a car. What kind of action is required? Because if bike is in the mid of the lane, I can't go in the from that lane. But if it is on the corner of the lane, probably I can take slight change and deviation and by make the or overtake the person. But if there is a car, I definitely can't overtake. There are some logistics. So Zipline is one of the company I use my product and they develop their system. Those are the different rules and those are being used in Africa. So in Africa, the medical like African countries, medical facilities are not that much great, and then road infrastructure are also not good. So they need medical attention or on the emergency basis, they need some medical equipment. So these kind of tools are being developed. These kind of things are being developed over there. So those are the drone. You need to put that means operator will put the location, GPS location, and do the back with this drone. Drone will fly from this platform. It will go with high speed. It will go in the air, and once it launches there, it will start navigating towards the given direction. Sorry. And once it goes to the designated area, it will drop that box on the ground from really good height, but they will take care that it should not be broken. And then the person nearest to that person, they will get alert that, hey, I'm dropping the box. Nearest person will go there and collect the box, and this zip line, it will come back. So this is the thing. We are in the trial phase now. Don't use for Amazon delivery or some of the delivery purpose. We are using the drone use, but this use is already started and it's in the production at this moment. That means AI is used for the delivery. Let's say crop. So in the agriculture field, drones are drone will take or satellite image will be collected from of the crop, and then 1 minute. Sorry, my battery was down. Okay, so based on the satellite image or based on the drone image, it will decide my crop, and then it will predict my crop's yield. It will detect production output. It's going to detect the disease. Is going to detect the health of the crop. So going forward, this is in the research phase, not applied 100% in India. We are working on that. But going forward, this will be used for the crop detection purpose also. Okay, now your IoT is one of the things where the smart devices will communicate with each other. Your health will be communicated over your mobile devices. Those are the things. So let's say you have the motor, you have the smart sprinkler. Those can be turned on and turned off by using remotely. Those are the system. You have some of the many decision that presently farmer are going in the farm, turning on the motor or changing that certain directions. Those will be done without going really. They can sit in the home compound and do those activities and monitor those activities on their mobile. So As one of the things I showed you that okay, we train those algorithms for a different kind of animal or plant or shapes. Similarly, we train those for the crop detection, which kind of crop it is. So it's showing me this is my crop. Is it healthy or not? What insect it has? What medicine shall I use? And then it will help me to order those medicine from where to purchase, and it will make some it may happen that those will be delivered at your comfort and then apply those. So those things are comfort is being used. Then market forecasting. Let's say crop detection. Last time this crop was what was the produce, what was the cost based on. Don't think that is always increasing. It may decrease also. Let's say we have unpredicted weather. We don't have control over the weather, rain, or so. So in that case, based on the weather, it forecasts the crop, and based on the crop produce, it forecasts the price also. That's how it will help us. Now in the energy sector, is going to use in the grid. So whatever energy being used, how much energy, what are the consumption? Let's say in winter, most of the people, especially north side, cold wave. Because of the cold wave, most of the people turn on the heater. Most of the time, heater is on. That means at night consumption is high. Then in the summer, we turn on the AC. So nighttime or daytime, that AC is high. So we detect that seasonal thing or it's a daytime, those detection of the energy and the grid will be forecasted. Then AI will be used for the renewable energy optimization, the increased efficiency, cost saving, grid. There are multiple algorithms, but how is going to impact you? That I am telling you. How it's based on the algorithm again. But this will be used in the AI also for the renewable energy. Now, energy forecasting, energy demand cost, that will also be the way produce demand is there. So any industry demand can be forecasted. Okay. Now there are something legal compliance. So AI can be used for the documentation review, contract analysis, prediction, or the compliances also. So legal industry or the compliant industry, it will check. If you give any scan copy to your LLM, you give that, you try yourself that, hey, this is my rent agreement. Read that and tell me whether this rent agreement cover all the core clauses to make me safe as a owner. It will tell you whether that contract is good enough or not. Or suggest me some of more contextual term. It will suggest to you. Okay. In the media and infotainment, many of you use the digital media now. So many of you use uh, for YouTube. Many of you use Amazon, Netflix. So once you watch one movie, it will recommend you another similar type of movie. Once you watch one video, it will recommend you similar. Those are the forecasting. So that's being used so multiple ways in the infotainment industry. It can be used. Now, most of you are from the education industry. So can it be used in the education? Some of you are MBA student. You will be going to the education sector, hospitality, then automotive, industrial application. So how it's going to impact? I told you, but education industry, how is going to impact? Yes, there is going to impact the education industry also. Is going to impact the personalized lesson. You being the fast learner, slow learner, average speed learner, it will help you to personalize your learning platform. Then automatic grading. I am developing one software at this moment for education industry where your written paper or your grading system will be automatically done. You scan your paper, give it to me. I will upload in my software. and automatically it will say that what is the grading. Yes, so teacher's presence for the correction of that is not required. It will himself will say what for each candidate, what are the improvement area, what is the strong area, weak area. Those I'm developing at this moment. AI and the predict analysis, performance analysis for the student also can be done. These are the some of the university problem in the education. So it can solve the administrative problem, office problems, marketing problems, students problem, lab, and helping professors. How it's doing that? So I problem administrative problem. So it multiple student have multiple queries. It can create the chatbot. It can and then it gives the frequently asked questions answer. It can create the smart campus. So multiple ways it can help university. AI assistant documentation processing, whether document is good enough or it's not good enough. So no person is required. It will automate or help the office boy to take the decision correctly, because office boys are not equipped to analyze is this document correct. Office boys, no, if you are doing PhD, office boy doesn't know your degree is real right document or not, because he's not gone through that process. But our AI system will detect that. Workflow optimization. What is your workflow? Make the fee, make the payment, then go through this assessment, then this assessment. Entire workflow will be developed. Multiple marketing, when you are promoting your school, college, university, it can be AI can be used for developing and taking the right decision and data-driven decision and to the right forum. It can help professor. Professors are the main asset. Teaching faculty are the main asset in the education industry. So AI can help them to evaluate the assignment and the exam. Now I'm developing the software for this, that whenever any assignment is given, you scan those assignment or put down the assignment. You don't have to really put your effort towards that. It will, my system will evaluate all the assignment, all the exam, and then it will give you the output. But hey, this kind of thing. Content recommendation will also be given. What kind of study material, where to use. Let's say if you are MBA student, and then if you want to learn certain theory, you just put in the Copilot, I want to learn this theory, 3-box theory. Please give me the YouTube content or give me the reading material. It will generate. So content recommendation. Lecture enhancement is more interactive, and then your professor's energy can be really used effectively to solve the problem of student. Lab also can be designed effectively so that your engineer or your student can use and make the lab automate. So then getting the funding, you can write the proposals, data-driven decision, predictive analysis. So this also can be done. It can help the student also in the multiple way, personalized learning, AI tutor, career guidance. His mental health is also important. So this way, it helps education industries also in the multiple way. To cut short and to say that AI is in initial phase, we are in the initial phase of the AI. If somebody is saying that we have already advanced the AI, no, we are just in the early stage of the AI. AI was known to many people in the recent age, but as an engineer, we started developing multiple algorithms many years back. Now, luckily or eventually market supported, and it become an ecosystem turn into such way that it become available to all the people and become very popular. But AI going forward is going to change lot of things, lot of jobs, lot of way of working, is going to change your day-to-day activity, your home, your office, your drive, everything is going to change. So My recommendation to you is start learning the AI. As a part of learning the AI, I'm not asking you to learn the language, do the coding. No, learn, make use of the AI. Start learning the chat GPT. Being a professor, you should start promoting your student to learn the chat GPT, give the assignment to them where they can make use of chat GPT to take those assignments. So make you more like in the industry, they need to use those tools. So why not to teach them in the academic? So that's the end of the presentation. If anybody required any support from my side, if you have certain idea, certain project, or if you need my support to solve your industry problem, you can always reach out to me on the given number. Thank you. Thanks. I know that this was long enough. And then my intention was not to go in the too technical things. My intention was to cover the how it's impacting the most of the industry and what way. But I can go to too technical, but it will be not of interest of most of the people. If anybody want to go in the technical things, I can take separate session for them. And if anybody need to work with me and solve their problem, they can always approach to me on the given mobile or the given number. That's it. Thank you.
Thank you, sir. A very wonderful, simplified presentation for everyone to understand.
Ma'am, can you tell me, are you able to see my presentation or it was not
come
visible?
to your last slide, sir.
Okay, okay. Perfect. So you was able to see my presentation, right?
Yes, yes.
Okay.
All
Thank
slides able to see, sir.
Sure. Thank you.
Very nice presentation, sir. A layman who doesn't know what exactly is happening with artificial intelligence all around us, it would be really understandable to all of them, sir.
Yes, ma'am. Savita, Sahana, ma'am. It was a very interesting and easily understandable topic.
Yes, yes, yes.
Presentation, yeah.
Yeah. You have a doubt?
No, ma'am. No, no.
Somebody has
ma'am.
raised their arm, and you can unmute
Yes,
yourself
madam.
and ask, sir.
Yes, madam. Thank you. Yeah. Good evening, Sajin sir.
Good evening, sir.
It was really a wonderful session. I enjoyed a lot.
Yeah, thank you.
So I would like to know from you one question I have, sir. As an academician, we have to learn AI. So from where to start?
Okay. So AI, which part of AI you need to learn? That you need to learn the chatbot, you need to do the coding, you need to do the algorithm, that, or you need to understand, see, which part there are, or AI automation, then there are some predictive algorithms. So many things. It's a vast thing. What is your need? That need to be understood. Let's say I need to check my mail. I have written something low. So many mails comes to me. Similarly, my boss mail come to me. So my boss mail should go on the always high priority. Okay, my team's mail should, or customer's mail should go to high priority. Some escalation mail should. So I don't have to categorize the thing. So I written one kind of machine learning classification algorithm. Okay, so those was non-code based. So what is your purpose? So I was aware that I don't have to write down the code. It was non-code based AI system. I have not covered that, but that can be covered. How to do? There are code based, non-code based. So which is your application? Based on that, you need to. But to as a general, if you are really interested in code base, you need to understand the Python, then data science, data cleaning the data, arranging the data, and then machine learning. Okay. If you are non-code based, then there are N8N and 8N. I will type. The N8N based algorithm. You can use this tool. Very good tool. 15 days. It's a free tool, free to use trial. You can use this tool and start developing. You can, within 2 hours watching the video, you can become expert yourself or new learner to the AI.
Thanks. So kind of you, sir. It's
So
really
can you mention that
wonderful
tool once
interacting
again?
with you and listening to your session. A very interesting session, sir. Thank you.
Thank
Thank
you,
you
sir.
very much.
Thank you.
Sir, can you please mention the tool once again?
In the text I have mentioned N8N.
Madam,
N8N
it is in the
set,
chat box, madam.
subset
You can.
Yes, yes.
N8N. Yeah.
Thanks.
It was a nice presentation, sir. Sachin, sir. I was also listening from the beginning. Thank you so
Thank you,
much.
Manoj, sir. Thank you. So
Sachin,
I am
sir.
not, just for information, I am not from I'm not the background where I have practice. I don't have practice of giving long sessions, but I tried, made my effort. I am the industry person. I am habituated of doing the decisions, taking the technical decision, driving the teams to driving the product. I don't have habit, or I'm not a good teacher, I can say, but I made my effort to teach you. If that is not powerful, I'm sorry for that, but I made my certain effort.
No, not at all, sir. Don't say sorry. Please don't say sorry. It was a good learning for all of us. It was
Sir,
really
it
good
is very,
learning, very informative, sir.
sir, it is very difficult to teach. It is very difficult to teach professor like us. But your
No, but sir,
presentation
we
is
are good
very good, sir.
teachers.
No doubt
We are
about it.
good learners, sir. We are very
Yeah.
good
Yeah,
students.
Yes.
yeah. Thank you. Thanks
We are
for
very
that.
good
Sachin
students,
ji,
sir.
it was very nice. Very nice. I was listening. Very nice.
Peter,
Once
ma'am, thanks for participating in this. It was wonderful that you are giving time to me.
very
Thank you
nice,
for
sir.
that.
No, very nice. It's very good.
Thank you,
Yeah,
ma'am.
very informative.
And
It was very informative.
yeah, and
Sir,
thanks for
once again,
recommending me, ma'am.
once again, tell the secret of AI, sir. Sir, you are give the one online program. Give me the details, sir. 15 days, if you are capable of doing, see the video, you can able to do a lot of things in AI. Please repeat the
Sir, it
website,
is
Sir,
in the chat, sir. Sir
Okay,
has
okay,
given it in the chat. Just
okay, madam.
check it in the chat, sir.
Okay, thank you.
Sachin, sir, may I ask one question?
sure, ma'am. Sure.
Sir, we are all dealing with Gen Z now.
Yes.
So Gen Z don't know what happened before AI. And they have AI without understanding what it can do productively.
Mhm.
So they're using it like a play toy. Actually speaking,
Yeah.
they use it like a play toy. And
Yes.
you were talking about giving them assignments on ChatGPT, let them learn. Sir, can you mute yourself, sir? Satyan, sir, can you mute yourself? Thank you, sir. So, Sachin, sir, when we are talking to students, we need to connect between theory and we need to tell them that in future they have to deal with AI. If they don't deal, they will become obsolete. So, what could be the specific areas where they could upskill or reskill themselves? Because sir, you have a very combinative background. You are an engineering and you have done an IM, so you know management part, you know software and hardware part also. But not all MBA students would be having this background. They would come from BCom, BBA, BSc, BA, any combination they could be. So how do we make the Gen Z upskill or reskill themselves? You know, the gap between academia and corporate, their career. How do we try to minimize that gap and make them identify the opportunities rather than making them obsolete very fast?
Yeah. Okay. So one thing is, ma'am, as they are using generative AI or AI as a tool, that is really good, because in our time, copying the things were not considered as a good thing. Okay, but going forward, they need to use, even I ask, or many of the industry, when we are putting the planning, we consider that we'll be using the team effectively by use of the generative AI. That means they will generate the code, they will create the proposal by using AI. That's our understanding. So when we know that open book system, in my college days, there was concept called as open book examination.
Yes, even
Okay.
I had this when I was studying open book test. Yes.
Yeah. So give them certain assignment, open book test kind of assignment. Ask them to search over the, instead of book, ask them to search over the chat GPT. Recently, last Saturday, I visited one of the college and I teach them how to do the survey in the industry, what kind of industries are there, what projects, how, which kind of participant. Then I told all the professor, I told that install the Copilot or Chat GPT. I gave them live assignment. I asked them, you search that. So you need to help them that, okay, industry wise, anybody is interested into HR, what are the HR role and responsibility, then what role are available presently in the market, which companies are available, then what challenges they are facing. Let them browse that on the given thing. Let's say Infosys challenge is different than the Intel's challenge. Intel challenge is different than the NVIDIA challenge. So let them, you give assignment, because those are not documented in the any textbook, is documented in their website. You give them assignment which will help them to make the latest AI things, and then ask them to present it. When presenting, ask them to make the use of generative AI to present it. Don't make simple slide. Make use of the generative AI so that they will start putting the one step now itself. So that way we can do it, ma'am.
Thank you. Thank you, sir. Thank you. Participants, any other question? Any query?
My 2 cents on that question, if I can, is
Sure,
we have to teach them the basics so that they can use Gen AI tools properly.
Yes.
So only after learning certain basics, they'll be able to do proper prompts. So that is a very big area of prompt engineering. So
Yes.
teaching them basics is actually making them more effective in using
Yes.
Gen AI.
Right,
Thank
sir. Yeah. For that, let's say if there is a text to image generation, you should be aware what are the different tools, which are free tools, what to use that tool. You should, or you can consult expert like me to upskill those. So many in one of the university, they have session of 1 week for the generative AI, completely generative AI.
Okay.
So that kind of thing need to be upskilled. Student need to be upskilled. And believe me, at our age or certain age, coping with the latest AI is really tough. I'm in that industry. Still, I'm facing challenge to cope up. So I can understand the difficulty who are not from those industries.
Yes, sir. Thank you, sir. Noted. I would probably start implementing it on my students because I do handle IT for managers, where I'll be talking to them about information system, emerging technologies, and
Yes.
so I would probably put them through all these exercises so that they could become, at least some inquisitiveness comes in them to, upskill themselves.
Yeah, sure, ma'am. Sure.
Thank you, sir.
Okay.
1 minute, sir. Sunita, ma'am.
Yes, ma'am.
Yeah, you can propose a vote of thanks.
A very good evening to everyone. On behalf of the Department of MBA, the Oxford College of Engineering, it is my privilege and pleasure to propose the vote of thanks for today's insightful session of the AICTE-sponsored Faculty Development Program on Next-Gen Management, Applications of Artificial Intelligence and Data Analytics in Business Strategy. I am filled with gratitude for the wealth of knowledge we have gained this evening. Mr. Sachin Rinde's presentation on bringing the notion of quantification and structure in industry knowledge has been nothing short of exceptional. With 24 years of rich experience spanning global product strategy, portfolio management, data science, and generative AI, he has provided us with practical insights that bridge the gap between theoretical framework and real-world business applications. His expertise in aligning cross-functional teams, driving strategic investments, and implementing governance frameworks has illuminated pathways for us to integrate AI and data analytics meaningfully for research endeavors. Our sincere thanks to our chairman, Dr. SNVL Narsimharaju Garu, for his visionary leadership and constant encouragement, which make programs like these possible. We extend our deep gratitude to our principal, Dr. Rakesh SG, for his continuous support, motivation, and guidance throughout this FDP. A special thanks to our Dr. M. Kadiravan, HOD MBA, whose meticulous planning and coordination ensured the smooth conduct of today's sessions. Finally, a warm thanks to all the participants for your enthusiastic engagement and active interaction. Your presence and involvement added great value to the session. Once again, we express our profound gratitude to everyone who contributed to the success of this today's program. Thank you all. Have a wonderful evening.
Thank you, Sachin, sir. I get in touch with you. Thank you. Thank you very much, sir.
Sure, ma'am.
Thank you. Thank you, sir. Manoj, sir.
Ma'am.
Shall we start, sir, your session? So, once again, a very warm good evening to all, ladies and gentlemen, professors of various colleges who have gathered here for the 5th day, second session. And I take this opportunity to welcome our second resource person of today's session, Mr. Manoj Kumar Lal. Sir is a business analyst at Tata Consultancy Services since 1997. He is a graduate from Indian Institute of Science, Bengaluru and BIT Sundri. He focuses on software engineering and the use of knowledge, better use of knowledge in IT. In his latest book titled Digitizing Industry Knowledge for Software Development, he simplifies a method which he first introduced in 2018, that is knowledge-driven development through this book was actually published by Cambridge University Press, where he talks about a practical approach which helps IT team make better software by organizing and using real-world industry knowledge. Sir is a very renowned person, both at the professions, with the professors, professionals, and students, where he interacts with them with structured information and helps them, in getting into various areas. With more than 25 years of experience in IT project delivery, his expertise is in requirement management, solution design, quality assurance, agile knowledge management. His practical approach helps his IT team make better software by organizing and using real-world knowledge into solving problems. He has also trained more than 150 associates in insurance domain with special emphasis on its usage in product development. Sir, I welcome you to this session. A very warm welcome to you, sir. And I hand over this pedestal to you where you can talk to us on the recent trends of AI/ML in industry, which is really ongoing all over the world. How do you structure this knowledge across various industries, expertise, the projects? And you could also share how it could benefit our coming generation, the Gen Z students, and the the next generation, the alpha, what do we do in order to make them apt to come on to this platform, either if they want to be entrepreneurs or they want to be work for an organization. So over to you. I would make you the co-host, sir, so that you could share your screen.
Excellent. Thank you so much, ma'am, for the nice introduction. And okay, I think I can share my screen.
Yes, sir. I made you the co-host. You can share the screens.
Okay. So is my screen visible? Right.
Yes, sir, it is visible.
Okay, so my screen is visible. And there's a first slide. I'm hiding it here.
Yes, it's
it's visible, right?
Yes.
Okay, good. So thanks again, and thank you all the participants for this late evening session. And before I start, I wanted to make one thing clear that I'm talking in my personal capacity in this session, and I'm when I'm allowed by this KDD Educations, which is my wife's firm startup. They're trying to take whatever idea I had written in the books to the reality. So I'm using their presentation only, and they have developed a tool around this idea that also will see in this session. So with that, let me start. But I just thought from the previous discussion when you people were saying open book exam, I remembered when I was doing ME in aerospace in Indian Institute of Science. If a new faculty had come, and he just came from US MIT, and he introduced this open book exam to our class, and 3 years ago when I went to the alumni meeting, he was recollecting me and he said, "I remember you." So I also had forgotten why he remembered me. Then he himself was telling that when we started the exam, and then he was saying that, okay, as much as time you need, you take it. So I mean, most of the people went by a stipulated 2 to 3 hours, but after that also 3-4 people were left. They were not leaving the room. So he was saying that, okay, you can go if you are done. And then I told him that, sir, unless you force us to leave, many of us will not leave. So that he remembered, and he was recollecting in our last alumni meeting. Okay, that's just to get the environment lighter. I will start with my topic. So although this is an AIML, trends of AIML in the industry, this is the broader topic name. I have done some basic research, and that was from the last 16, 17 years. I'm working on knowledge structuring. And it has got a very good relevance, as you're saying, in Gen AI, especially AI and Gen AI area, that we will try to visualize. And fortunately, as a byproduct of my research, it has created a very strategic offering for the academia that I'm quite interested to talk about in this wider forum. And we will see if it is interesting, and we are pretty much positive to take this interaction forward. Okay, so as the topic says, it is structuring knowledge across industry, enterprise, and project. We'll start with that. But I'll try to talk very basic things. So whenever whenever there is any question in the chat or anybody wants to interrupt, please do that. And we'll take the question then and there. And at the end, we'll anyway have some time to discuss the feedback. Right. So we all produce output, right? Particularly in the industry, we all produce output. So we produce software, which is an output. We build factories, which is an output. We build machines, which is an output. We manufacture medicines, which is an output. Now, an output can be delivered with quality only when we have required knowledge and execution activities aligned to that knowledge. So we can produce a very good quality output when we know what knowledge it requires to produce the output, and just knowing is not enough. We need to do some work also, so that using that knowledge, we actually produce the output. So knowledge plus execution activities equal to output. And that's what this sentence says. The knowledge is stored primarily in the minds of people and in unstructured artifacts prone to redundancy, inconsistency, and out of date. So two prime sources of knowledge. So it is there in your mind, it is there in your subject matter expert's mind that you go and ask them. And it is there spread across in hundreds and hundreds of documents, PPTs, blogs, everything, either in the organization or out in the internet, right? But then taken together, all of that, you can't say for sure that they are all updated and they're all giving you the correct information. So, for example, if you have written a requirement document and the project is done, and the project did not give you enough time to keep your requirement documents updated, then whatever is written in the requirement document is only half truth, right? And it remains in your repository forever. Now, this half truth requirement document is now an input to everything. So search engines, to Gen AI tools, right? So there are lots of information, but you can't say that this is the right information or not. So that's the main problem that I was trying to work on. I mean, way back in 2006 or 7, it struck me, and I have been till now also. I'm researching on a personal basis on this particular problem. As I was saying, that Gen AI provides direct response to the query, but it relies on the vast information base that it has, and I mean, we cannot guarantee that all its information base has got correct information only. And then most of the time, Gen AI is supplemented with knowledge of the organization, which is again in the form of these unstructured artifacts, particularly the RAG model of the Gen AI. So the responses is all okay or not, we don't know, we can't say, unless somebody knowledgeable enough comes in and he says, right, whatever Gen AI is giving is right, or it has got some issues. They say, okay, you correct it and then use it. Right. So Gen AI helps, but not in that particular context of giving you 100% correct information. KDD, knowledge-driven development. This is the name of my first book, which was published from Cambridge University Press in 2018. And through that, this terminology came, knowledge-driven development. And it is a framework that proposes a single structure that can cover the knowledge aspects of the output and because the knowledge aspects can now be contained in a single structure, it brings order in the whole area of anarchy that we have today in producing the output. So that's what is KDD. We'll have a look at this structure, what this structure is, and also provide a glimpse of how it accelerates producing the output. Now, although the main beneficiary of this structure is industry, its exposure to academia can plug industry-academia gap in a formal way. We'll cover this aspect also in the session. Now, this structure is domain agnostic and hence can assist various branches, including management, computer science, and other engineering streams. So, if many of you may recollect BPM, business process modeling. Now, business process modeling is a domain agnostic way of specifying business processes. So it works in all the domains, all the industries. Like that, this structure is also domain agnostic. It can work in all the industries. That's what this last statement says. Now, again, to repeat few things from the last slide, but this is the key that I am quite interested to discuss interactively with this community, which is faculties, most of us, to look at this proposition critically, and if it makes sense, let's discuss it further. Now, proposal for seeding industry knowledge in academia. But what does that mean? The way we teach quality assurance, the way we teach project management, they're all domain agnostic, right? So any industry would need that. This, when we can't teach industry knowledge in that way, because obviously industry knowledge is not industry agnostic, right? Every industry is different. So if you are teaching insurance, that's one way. But if you have to teach banking, then the whole thing will be different, right? Banking will have their own topics. Insurance will have their own topics. And for that matter, any other industry will have their own topics. But so what it says is, despite the presence of expert talks, internships, related assignments, and one-off optional courses that we see, like finance, academia still lacks a formal mechanism to seed industry knowledge. So when I say formal mechanism, it should be standardized. It should be accepted, standardized, and it can be used across industry. So that is not there today, right? In Mumbai, many colleges would teach insurance because most of the insurance companies are headquartered in Mumbai. So like that, we have colleges preferring to teach a particular industry for specific reason of increasing the employability of students. But there is no formal way of teaching industry knowledge in an industry agnostic way. Is it possible at all? That is what we will try to understand in this session. And on the face of it, it doesn't look possible, but we are claiming it is possible. Now, why we are not able to seed industry knowledge in academia? The root cause is, with so many vast and diverse industries, students are unsure which one they will eventually join, and that's the most important cause. Companies provide domain training anyways after hiring, so that again, doesn't encourage academia to think about introducing domain knowledge. Industry knowledge is rarely tested in interviews, correct? And many faculty members do not have industry experience. So these are some of the main reasons why, even if we want students to have industry knowledge because it obviously would reduce industry academia gap. But due to all these reasons, we are not able to. So it's an open gap. It is still to be plugged. So KDD framework provides a domain agnostic way to structure industry knowledge, enabling its formal integration into academic programs. All okay till now?
Yes, sir. Continue, sir.
What yes, okay. So going next is, what is KDD? What is knowledge driven development? So KDD structures and links industry and enterprise knowledge, reuse enterprise knowledge for quality project delivery. So till industry knowledge, it is relevant for all the streams of engineering and management. Then it moves to enterprise knowledge. Again, it is relevant for most of the streams. And then it moves further for quality project delivery. In this context, we mean software development. So that is of relevance to computer science and related branches. We'll focus mostly on the industry knowledge because that is what we lack today in academia. We don't have formal way of teaching industry knowledge. We'll focus on that. The other bits of enterprise knowledge and software development we'll touch upon, but I will not spend too much time on that. Now, just to give these terms should already be known to most of us, but again, just to clarify, unstructured knowledge is the knowledge contained in artifacts such as documents, PPTs, Excel sheets, blogs, articles, those type of things, audios, videos. And structured knowledge is the piece of information which is stored in a structured format. So BPM, as I said, BPM, business process modeling, has a specific way of storing processes. Rule engines have a formatted way of specifying business rules. Data flow diagrams is a structured way of capturing data. Right. So that is the example of structured knowledge. Now, what we do in KDD is take the unstructured knowledge and put them in a specific structure that KDD recommends. And the difference here is it's not just data or process or product or business rules. It can contain all the aspects of industry knowledge. So it can contain data also, rules also, process also, reports also, communications also, KPIs also, non-functional things also, utilities also, everything it can contain. And that is the differentiator. We do have structures today, but those structures contain only specific aspects of industry knowledge, like process in BPM, rules in rule engines. But this particular structure of KDD can contain all aspects of industry knowledge. If that can really happen, it will be a magic, and then it will have a positive impact in everything that we do. So let's go further. The too many terminologies, I will probably skip that for the sake of time. But these terms I will certainly like to explain. Industry knowledge, enterprise knowledge, and project knowledge. What is it? So through the example at the bottom, taken from retail banking industry. Now savings account earns interest. So it is 2%, 3%, whatever is percentage we have in our savings account. is an industry knowledge. So industry knowledge will never say that 2%, 3% or 4%. It just says that if you have a savings account, it will earn some interest. Now a specific organization, so let's say State Bank of India, and the bank account that you are having, that may have 2.5% of interest rate. This knowledge will be enterprise knowledge of SBI. And project knowledge is you are trying to improve the enterprise knowledge for various purposes. So if there is a need to change the percentage from 3.5 to 3% interest rate, that will be done through a project, and then that will become a project knowledge. So these are the through this example, I just wanted to make it clear when we use this terminology, industry knowledge, enterprise knowledge, and project knowledge, what does it actually mean? I'll go further, and it tells me the same thing. So I'll not repeat it. It just says that gather the generic knowledge about the output, then gather the implementable knowledge about the output, and then use that knowledge to in your execution activities to produce an outcome, which in the specific case will be software development. Right? So now, without wasting further time, I would like to go to the tool that career educations are developing. And through the tool, I would like to demonstrate how the entire industry knowledge can be specified in a single structure. Now, before I go to the tool, I wanted some basic terminologies to be made clear. So let's spend a couple of minutes over here in this slide. You can see three boxes: industry knowledge, enterprise knowledge, and project knowledge. Meaning you already know now. The industry knowledge structure, there are 3-4 terms that we need to understand before going there. One, H, product, then we have process, then we have node, then we have nugget. So every industry will have its offering. That offering is called product. Now, in case of banking, retail banking, what will be the products? It will be savings account, fixed deposit accounts, recurring deposit accounts. What will be the products for life insurance? It will be term insurance, it will be endowment insurance. And what will be the products for pharmaceutical industries? It will be various types of medicines and such offerings. So products are offerings of the industry. And then the other terminology is process. What is process? Processes are life cycle functions of products. Right, so what are these life cycle functions? Broadly speaking, there will be only 3 functions. One is to launch the product, other is to administer the product, and the third one will be to decommission the product or withdraw the product from the market. So those are the examples of processes. The products and processes form 2-dimensional matrix, which you can see through the curved lines, and the intersection point of that matrix is called node, which is a storage point of knowledge. And the real knowledge is specified in the form of knowledge nuggets, which are placed at the storage points, which are, that is nodes. So at each node, there will be lots of information in the form of knowledge nuggets. Knowledge nuggets will be in the form of sentences. They will represent a unit of information, mostly in one sentence or sometimes in multiple sentences. but they will convey a single unit of information. So that is the basis of industry knowledge structure. Now, as you can see, when we said that the industry knowledge structure that we have devised is in domain agnostic. Now, we call it domain agnostic because product is domain agnostic. Every industry will have offerings. Processes are domain agnostic because every product will have their own processes. And storage point and the real information, which is in the form of nodes and nuggets, they are also domain agnostic. Right, so every industry will have real knowledge that we need to specify. And this structure is hierarchical. Now, to visualize that hierarchical structure, you can see in the enterprise knowledge upper portion, and you can see that from the node of a parent product process mesh, another product process mesh takes birth. And in the child product process mesh, what happens is the product at the intersection point gets split into next level products, and process at the intersection point gets split into next level processes. And then this continues till the level where the products match directly with the products offered by the domain companies, and processes go to the extent that if you further dissect those processes, it will seem to be a step, not a function. So this is in entirety the industry knowledge structure which we will see through the demo. And let's touch upon this enterprise knowledge and project knowledge also. In enterprise knowledge, we have industry knowledge. When we have used industry knowledge structure, although the information will not be from industry knowledge, it will be from the enterprise, from the organization. But additionally, it will also have IT knowledge, business knowledge on the upper side, and IT knowledge on the lower side. And IT knowledge is also hierarchical. You keep breaking it down, and at the end of these breaking downs, IT knowledge and business knowledge are at its last level of details. They talk to each other, and through exhaustive traceability, both IT and business knowledge are talking to each other. In fact, IT is implementing a business process in this manner. So seeing enterprise knowledge in this manner simplifies things and makes it easier to structure it in a way which is quite understandable to a common person. And it is a replacement of hundreds of documents that you see in the enterprise today. Using a portion of the enterprise knowledge, we can create project knowledge. So take a portion of the enterprise knowledge, amend it with the requirements of the project, and once that is done, the knowledge aspect is done. Then execution aspect starts, and in this software development area, execution aspects are your development and testing. Knowledge aspects are requirement and solutioning artifacts. Requirements and solutioning artifacts are taken care of in this structure. Don't have to produce those documents. And once this structure, the information in the structure is finalized, you just have to do the execution activities, which is build and testing. Okay, so we now give a little pause to this deck and go back to tool, which will allow us to understand how the entire industry knowledge can be specified in a single source of truth through this industry knowledge structure. So this is a banking, not a banking, this life insurance domain knowledge that we are trying to capture here in this example. I will click on it. I'll go to display information, and there are three levels by which we understand the entire industry. The first one is contextual knowledge. So there are 8 topics, which is again domain agnostic. Every industry will have same topics. Name will be the same. Introduction, evolution, is history, characteristics of the industry, departments of the industry, IT applications of the industry, stakeholders of the industry, regulatory influence, and latest trends. So the first thing we do in learning an industry is to go through each of these topics. We click on that, we get nuggets, which is unit of information at this level, all clubbed into a tabular format like this. And then one by one, we understand it. If it is a lecture environment, the faculty will go through it one by one. Clicking on it, this is a specific nugget which is telling us about purpose of insurance. And this is the real understanding of the purpose of insurance. It says there is always a risk to life and business. Often the realization of risk results in significant financial loss. Insurance protects individual and business from such potential financial loss. So the teacher will tell these sentences, explain it, and if there are any relevant material to refer to, they will show you that. Right, and this is how we understand the contextual knowledge of insurance through these particular topics. Once it is done, we come back and hit on and there's a glossary also, of course, and the beauty of this glossary is it's not just standalone pieces of terms and explanations. It also tells you when it is where all it is referenced in the knowledge base of life insurance. So OTC is a term, over the counter in life insurance, and which transactions of life insurance are OTC transactions. Clicking on OTC will give you the list of that. Right, so it's not just standalone terms, it also tells you the references from the main knowledge base, detailed knowledge base. Then we go to the structured knowledge circle, click on it, and click on multiple selections. And as I was explaining you, this is insurance domain. So insurance has got 2 main types of products. One is general insurance, that is property, motor insurance. Another is life insurance, which is term insurance, when it covers risk of death most of the time. So these are the 2 products of insurance, and these are the 5 processes, top level processes of insurance. And as I was saying, that these are the rectangles, are the nuggets at this intersection point. So these nuggets will always talk about life insurance products and individual policy life cycle management process. So for these 2 intersection, for this product and this process, whatever is relevant for us to know, it will all be specified in the form of nuggets, one by one. Again, in a course delivery mechanism, the faculty will take you through it. Or in self-learning mode, the students can themselves go through it, and they will start learning the next level information about life insurance. So which is detailed than the contextual knowledge that you have seen, but it is not, it's still not at the last level of details. Now the real beauty is over here in the node, in the storage point. Now be careful that it is life insurance product and it is individual policy life cycle management process. If we click on this node, what will happen is individual policy life cycle management process will be split into 5 next level processes, and life insurance product will be split into 2 next level products. And this will go on. So for example, life insurance and individual life, if we click on, it will go to level 3, where new business will be split on these 7 next level processes, and individual life product will be split into 3 next level products. And let's go to the next level. Financial need assessment process is broken down into 3 next level processes, and endowment product is broken down into 4 next level products. Now any life insurance policy that you will see, they are either of this type or this type or this type or this type, if they are of endowment product. So we will stop here at level 4. This regeneration of product process stops, because products are directly mapped to the products offered by life insurance companies, and these processes are at the last level. Breaking it down further will give us a sense of that it is no longer a process, it is now a step or activity. Now, at this level, as you can see, we have broken it down into 4 levels. So at 4th level, the information, the level of information will be equivalent to the level of information we see in requirement documents, in solutioning design documents, to all the last level of details that we see in our unstructured formatted artifacts. Those information are kept here. Right, so these are atomic level of information at level 4, which is the last level of information. For IT and business folks in the industry, they don't need to go any further splitting than this. This is at the last level of splitting. Right, so this gives us an ability to improve our project delivery. So for example, if we want to know that for changing the name of a policy holder, what all business rules are needed. So you just arrange it as per business rules. It will start giving you the business rules. So these are business rules. You may not be able to read what is written here, but I'm just making you visualize that these are the individual business rules of when it comes to changing the name. If for some reason it is incorrectly spelled in your policy documents, this is the business rules which are required for changing the name of the policyholder. So what is this? For example, insurer must reissue policy document with corrected name. Right, so just changing the name is not enough. Insurance company must reissue the policy document, which will have the name. So the updated name must be there in the reissued policy documents. That is a business rule. So it must happen. If some insurance company doesn't do that, that is an issue. It has to be corrected through a project. Right. So the last level of details comes through level 4 knowledge nuggets. So I will not take too much time now on this. It's already 8:28. I will try to prove the domain agnostic nature of this particular structure by browsing certain other domains. Like let's see banking. When we go into banking, as you can see, topic names are the same, just the information will differ. Now, this is purpose of banking, business model of banks, how bank works, retail bank, corporate bank, investment bank, consultancy provider. So at this level, whatever information is contextual knowledge of banking, we learn that. And then we come into product process mesh. Now, if you see, the structure remains the same. It's just the information which changes. Now, in banking, there are 3 broad verticals. Retail banking, click on that, it will give you the definition. Corporate banking, investment banking. And then you can drill it down further. Level 2, to corporate banking split into debt products, liability products, trade finance products, treasury products, project finance and corporate. And then in the administration, product administration, account administration, debt products, if you go to level 3, it is priority sector loan, term loan, working capital loan. And in the account administration, due diligence, sanction, disbursement, monitoring. So you can see the structure remains the same. It is relevant for all the industry. Let's also take a quick look at one more. Which one? Okay, automobile. Structure remains the same. The information changes. This personal vehicle, commercial vehicle, special purpose vehicle. If you do manufacturing, it is. So personal vehicle gets into motorcycle, scooter, car, utility vehicle, final assembly. If this splits, final assembly is split into interior, exterior, and accessories, battery and entertainment system, final inspection, and different types of different models of car. And there is 4th level also, types of sedan, and then final inspection, exterior inspection, and all those things. So all I wanted in the last 15-20 minutes is to give you a broad visualization that there is a new structure which has come in that can capture all the industry's information in a domain agnostic way. So due to that, it becomes a skill like design thinking, Six Sigma, and other skills. And to learn that skill, we need to know what is called product, what is called process, what is called node, what is called nuggets, what is called product process mesh, and then start using it in the industry that you're interested to learn. And in the same spirit, I would also like to go a little bit further. Not this one, first one. Because we are claiming it is domain agnostic. So let's look at it from mechanical engineering perspective. So starting with education. Now education has got these, how many? 3, 4, 5 mainstream: management, medicine, engineering, humanity, science. That is one dimension. The second dimension is beginners, intermediate, advanced, and expert. Now, if it is engineering and intermediate, then the next level product process mesh of that engineering and intermediate will be engineering, computer science, electronics, electrical, mechanical, civil, and here learn, evaluate, and relearn, that intermediate level. And then if mechanical and learn is split to the next product process mesh, it will be different streams of mechanical engineering. And here learning, what was that? Learn, it will be theory and practical. Thermodynamics and theory, if we pick, the next level will be zeroth law, first law, second law, third law, and concept and numerical. And you have already seen there, these are knowledge nodes. On top of it, there will be knowledge nuggets, which will explain, like knowledge nuggets over here, will explain first law of thermodynamics, the concepts of it. And here it will have numerical examples. And if we, I mean, some examples of nuggets are these. Now, I don't have time to read all of this, but as at a conceptual level, I think you would have got what I actually wanted to convey. In pharmaceuticals, these are the main products: drug delivery devices, medicines, health supplements, biopharmaceuticals. And these are the processes: discovery and development, manufacturing, marketing, and sales. These are level 2 splits on all these 5, 6 level ones. Not going to go through them. I also don't understand many of them. My daughter and others have helped me in creating this particular mesh. Right. So we have seen we were in the demo side. We had seen accelerated domain learning because the knowledge is now structured. We had seen cross-domain relevance. One structure can be used to learn multiple industry. And accelerated project delivery, it is particularly useful for compliance branches. I think we are at 8:36. I don't want to delay you people too long. So I will probably have to skip this area, accelerated project delivery, because it is only relevant for computer science. But I would like to come back to the topic we were discussing just before I started from the previous session. Now, what this particular thing does is it helps you getting the basics of industry knowledge so that you can become a good prompt engineer, so that you can ask proper questions from Gen AI. And that's probably one of the questions that we had in the first session, right? When we said, okay, how to make people use it and how to tell them to use it in a better way. So I will show you some examples in the tool itself. So if I click on it and if I click on the search information, I go to a ChatGPT type of interface. And what this ChatGPT type of interface does, I mean, this is a RAG model. What it does is it goes to the information which is there in the structure. It retrieves the contextual information from the structure, and then it goes to the LLM, refines or sort of makes it more readable and throws us the output. So here if we say list out the top type and top level insurance products. List out the top level insurance products. So if we give this prompt, and let's see what it comes back with. It says top level insurance products are general insurance and life insurance. And why it told this? It told this because this has got only two types of products in our database. Sorry, I was in automobile, so you had seen it earlier, right? It is having only two products in insurance. I'll just show you so that I know these topics. Many of you may not have much idea about insurance, so I'm trying to demonstrate it properly so that we understand the underlying concept behind this and not the real domain that we're demonstrating here. So general insurance and life insurance, and that's what we want, right? So it gave you an answer which is much more predictable, much more with quality than you would have asked a normal chat GPT. So let's ask chat GPT also. Chat GPT. We ask the same question and see what happens. In fact, we just copy paste this. And why just this? Let's ask Copilot as well. So it says top level insurance products. First is life insurance. Second is health insurance. Third is general insurance. Fourth is group insurance. Fifth is reinsurance, right? And let's ask that same question here as well. It says life insurance. It says health insurance. It says general insurance. Right. So here it gave you three. In ChatGPT, it gave you 5. And in this KDD tool, it gave you 2. Right. Now, there's no right or wrong answer. In industry environment, some people would say that, yeah, group insurance is also there, why not? But some people will say group insurance will be the next level of details within life insurance and general insurance. So they will say no, 2 is enough. Some people will say reinsurance is also a next level, it's top level insurance product. Some people will say no, reinsurance will be the next level 2 insurance product, not level 1. Right. And many people will say health insurance is not part of insurance. It is a different stream altogether. Healthcare and health insurance is treated as a separate entity altogether. Right. So these are the reasons why all 3 answers are correct. But then for us to work in a specific organization, in a specific context, we need to have a clarity so that if you ask how many top level insurance products are there, it should not give you different answers different time. So if let's say if an insurance company adopts this KDD model that we have just seen, and it wanted its users to be given this answer only, because it has only general insurance and life insurance, they can be fairly sure that, okay, it will not hallucinate. This RAG model of ChatGPT that we have used API and got the context from our information, will not hallucinate, will not give you wrong answer. You type it again and again, it will keep giving you the same answer. And that's something which doesn't happen normally, right? Every time you type the same question, it gives you different answers. Right. So and this is very basic, right? I mean, the products are there, processes are there, notes are there, nuggets are there. And the entire life insurance information, if we put it, my guess is it will be from 3 to 5 MB. It will not be more than that file size of this whole life insurance knowledge. That is fit for purpose for IT and business folks. It will not be more than 4-5 MB. And we see GenAI fellows, they are petabytes and petabytes, and there's too much information over there, and that makes them prone to hallucination. Because if there are 100 sentences which are correct, at the same time there will be, let's say, 10 sentences which are wrong. Now, we can't predict that when it will pick up from the 100 correct sentences or when it will pick up from the 10 wrong sentences, right? So we'll always be confused. Although it has got millions times more volume of information, but then what is the use of it if it doesn't give you the right answer? Why don't we go back to the basics and say that 25,000 sentences of life insurance, you extract them from various documents, put them in a single structure that remains single source of information for everything that you would like to know about life insurance. And that's where this whole thing starts coming to. I will have to stop this demonstration here now, and I will go further in this area. Mechanical and pharmaceuticals are covered. And the last few moments, I will go back to the to the initial discussion we were having. Now, in the software development area, there are only two basic skills that we need as a developer, as a main participants of project delivery team: technology skill and domain skill. Domain skill, which is the skill of insurance, banking, retail, pharma, and everything, that can be taught in a domain agnostic way that you have seen. And I think you may have visualized it also, how and why we are claiming it is a domain agnostic skill. And academia is very good in teaching domain agnostic skills, right? So we teach them project management, we teach them requirement management, we teach them quality assurance, all domain agnostic. Similarly, we teach domain in a domain agnostic way. And this is very difficult to visualize. But then if you would have observed this half an hour demo, you would feel comfortable that domain can be taught using a domain agnostic skill, and that makes it very easy to formally seed domain in industry knowledge in academia, because it introduces domain knowledge, industry knowledge in a domain agnostic way, which academia will not have any issue. When we say, okay, we teach insurance, we teach banking, we teach retail, then they will start getting confused and they'll say, okay, so much vast is there, our faculties may not have that background, and all the students don't know which all those things that we said in the beginning comes into picture. But if we say that no, we'll only teach product, process, mesh, and that thing, which is a skill to understand domain knowledge in a domain agnostic way, and then use that structure to teach a couple of domains at high level, and we will also teach few domains at detail level, so that that can be part of the assignments in digital technologies in software development area, like fraud analytics and such things. That will plug industry knowledge gap in a very formal and transparent way. So that was for software development. And for management students, right, we have students from HR, finance, marketing, and such horizontal streams. And if there is a domain agnostic way of exposing them to vertical domains as well, such as insurance and retail, as I said, we will make a better HR fellow, we'll make a better finance fellow, we'll make a better marketing fellow, because they will be exposed to the domain agnostic way of learning vertical domains, vertical industries, the real industries that go, right? So there are few companies which are only focusing on HRs, but most of those students will go and work in the real vertical domain, industries, vertical industries. Now, if they have this domain agnostic skill, in whatever industry they go, they know that there is a scientific way to learn that vertical, learn that industry, and that gives them an edge compared to the student who doesn't know this skill. So that's for management. And for engineering stream, we had a short demo for mechanical engineering. And I think the best way to introduce it is like, let's say in the first year, first semester, there will be a course based on the structure, which will tell you that what all is going to come to you till fourth year in different topics, and some short explanation on that. It can be beautiful. It can be beautifully structured in the in the way we have just demonstrated it over here. Right. So this is an interesting thing. Today, what we write in our CV as a graduating student, we say that, okay, I'm very good in communication skills, I have good technology skills, I have management interpersonal skills. If additionally we say that we have a basic understanding of industry domains, I think it is obvious that the industry will be more interested in this resume than this resume. And as I was sort of hinting initially, we will not bombard them with the finer detailed information about the industry. We'll focus on teaching the skill to learn any domain that they want to, domain agnostic skill through KDDA structures. Then we will teach 3-4 industries, which covers maybe more than 50% of the IT and business workforce. So let's say BFSI, retail, pharma, that 3-4 industries will pick up, and will, let's say, only focus on level 1 and contextual knowledge, will not go any further than that. And then 3-4 topics will pick up, which will be at a detail level, but with a very specific focus on which assignment in which stream they are going to provide domain knowledge for. And for IT branches, we will focus on how this industry knowledge structure helps us in doing a better job as a software developer. So these are the things which can easily be taught by the academia to seed industry knowledge to the students, and that should obviously increase their employability. Now, for next steps, our broad thinking is this type of sessions of 2 hours, 1.5 hours should be able to make relevant stakeholders visualize what we are talking about. And after that, we can have a day workshop. What this day workshop will allow students, they will allow students to add industry knowledge in their first line of the CV and justify to some extent why they have added that particular thing. We'll plan to cover those topics which will allow students to add and justify why they have it in their syllabus. And then if we go further down in the nearest areas of the subjects that we have in various branches, like in software engineering, where we anyway teach domain agnostic topics, we can introduce KDD as another topic, which was there for a couple of years in BMS College of Engineering for their MCA syllabus, because the faculty over there was pretty much impressed from one of these sessions that we are having today. And he said, sir, we will get it introduced in the syllabus and then we'll call you for the session. That we did for 2 years. And after that, the faculty moved on to different area, and the new faculty who came, he said, what is KDD? Nobody knows about it. Get it off. So that was just 2 years. There are many positive attempts we have made. For example, in ICFE Dehradun, it is added in various subjects because one of the professors found it very interesting. It is also added as an open elective chapter in software engineering for CSBS, which is taught in 50 to 60 colleges, a branch supported by TCS. And in Jharkhand University of Technology, it is still there in their syllabus for 7th semester IT and computer science. But there's nobody who is teaching it actively, right? So I don't want to make big claims. So this is where we stand today. But people who give time to understand what it is, they are quite positive. They are not able to take it further because of various reasons, that they're government colleges, there's no there's no sort of opportunity for them. But the most important reason is, they say if the students are not being asked this particular domain related things in their written exams and interviews, then why will anybody study it? I'm being quite self-critical, so don't take it negatively about this proposal. But then I'm being practical, and actually industry should be the main beneficiary of this. I mean, industry should force, or industry should encourage academia to have such courses, because it reduces the effort. It reduces the effort that they need to spend anyway when the students go there. So I think I'm at the end of it. So I'll close in 2 minutes, and we'll start discussion. I think I shouldn't have anything much other than this whole idea of Indian Institute of Functionality. This is my mentor, whose name is Anil Kant Chaudhary sir. He says that whatever we have done is a very strategic piece of work. So there are colleges like IITs which teach technical things. There are colleges, MBA colleges, which teach managerial things. In the organization, we have procedural things also, but that is specific to organization. So like what is their dress code and what is their leaves and that type of things, HR type of things. But functional knowledge, there's no single institute like IITs for technologies and management schools. For functional knowledge, there's no single institute which teaches all sort of functional streams. Right, like IIT teaches multiple engineering streams, management colleges teaches multiple management streams. Like that, if there is something called Indian Institute of Functionality, which teaches, so a department is insurance, another department is banking, another department is pharmaceuticals. This whole concept of KDD can enable such an institute. And I think I'll stop over here. We have institutes which teaches insurance. We have institutes which teaches banking. We don't have one institute teaching. I mean, multiple such industries, and KDD structures strategic sort of ability is such that it can facilitate something like this in the Institute of Functionality. I will have to stop here. The first book, it's all there in Amazon. First one is named in Knowledge Driven Development, Bridging Waterfall and Agile Methodology. That started as a software development type of thing, but it has evolved and it has become much broader than software development. So my second book is Digitizing Industry Knowledge for Software Development. Again, just one or two chapters are there for software development. The remaining chapters are focusing on industry knowledge itself. We had presented it in many forums. We have papers published, and Jharkhand University, there is a link which says that it is still there as an open elective. And KDD Educations is trying to take it up further. So they can be contacted. I'm very active in LinkedIn. Manoj Kumar Lal, if you type, you can easily get me. I keep writing about these concepts. So we'll be very happy to get connected over LinkedIn. And I think 9 o'clock sharp, I'll stop here. Thank you so much for remaining in the session still. And the count is 133, so that's very encouraging. I must stop here to take some feedback from you and any questions that you may have.
Participants, any queries from your side?
So I am here with a mission. It's not one more session. I keep trying that, but I think I would have spoken 30, 40 times in colleges. And most of that has been okay. Come, sir, we will like to hear about it. We go and deliver this lecture. But then nothing comes after that. And quite sensibly, because everyone is busy in their own tasks. And colleges, I have personally seen, is not so positive about experimenting with new things, especially when there is no demand from industry that we should train in such concept, because that is also justified, because this concept is a new one. Even industry fellows don't know about it. So, but that is where in the stage of evolution, this KDD age, one day I'm sure there will be people who will be after this idea. But till that time, we'll have to keep trying.
Sir, am I audible, sir?
Yes, ma'am.
Something is echoing.
Yeah, you're audible.
So your book is talking about digitizing.
Right.
And in your platform called KDD, which you were just talking about, how do you go
Right.
about with the digitalization of all the tasks over there?
So there are two things: the structuring and digitizing. Structuring is the structure that we have discussed. Digitizing is to put information into that structure. So it's not that we have the normal meaning of digitalization. I think is we have lots and lots of manual things. We scan them, we put them in a single repository in terms of some files. Right. So that's the traditional meaning of it. What I mean by digitizing is we are putting those information in this structure. I think in the name of this second book, there are 2 points that I still repent I didn't hear accept the suggestion from my mentor. He was saying that put structuring rather than digitizing, and don't put for software development, because your basic offering is is the structure. It is not software development. So his suggestion was just say structuring industry knowledge. Don't say software development, because that makes it very confined to a very specific set of audience. So now I am realizing that why he was saying that. But then once out, it is out. The name we can't change.
So that was one thing which I was having, because most of it you were talking was the digitizing part of it. But then how does the digitalization happen on that platform, or how is it?
It's done by industry experts. So insurance detail that you're looking at, they have been done by industry experts from insurance. So if banking things, well, it's half things only. It's not complete. But banking experts need to sit together. They need to decide what should be the next level product process. There are so many other considerations that those product processes should be mutually exclusive, and that is one of the preconditions. So there's so many things that experts need to sit together, and they need to populate those structures.
Thank you, sir. Thank you, sir, for this wonderful session where you spoke about a platform which you have designed and developed. So there needs to be a lot of probably we need to go into it a little more where we can understand on the usage of it. So only when it comes to the usage part of it, and it's just like how we start using something and then we become very close to it and we use it always. So as we use it, then we understand it. I think that's what I have understood out of this.
Absolutely. Absolutely.
Yeah. One question from my side.
Yes, ma'am.
Yes, ma'am.
Yeah. Actually, I want to know that suppose the knowledge of banking sector or insurance sector, this all student will learn, okay, by your course, and they will be capable. But in job market, from the placement point of view, do you know that what kind of company and all will come, so that we can tell to our placement officer, and I can think for our engineering student, so what kind of company, so that it will be easy for me to inform to our placement uh, sir, that this type of knowledge, domain knowledge, if our student are having, then placement will be easy, because you know that placement is a great challenge for every colleges nowadays.
Simple. But when we talk to training and placement officers, what they say that I get a request from HR of a company that send me the CV of 10 full stack developers. Send me a CV of 10 Java fellows. Send me a CV of 10 .NET fellows. Right. So domain doesn't come into picture. So even if TPO says that, sir, my students are expert in domain also, I don't think HR will appreciate what they are talking about. So that's the current reality. Now, what I am personally thinking it can go forward is only as a skill we will expose domain knowledge to academia, because we cannot do anything more than that. We cannot do we cannot make someone ready to work in insurance domain in academia. They have to learn the details when they are into industry. So to industry, we have to proactively approach them, and we have to say that look, our students would know a skill which will help them to learn whatever project you are assigning them to, whether it is of insurance or banking or XYZ, any industry. Our students can do a better job compared to other colleges students because they have the knowledge of a domain agnostic skill to learn domain in a more scientific way than their colleagues can learn. So that is what will make industries when they may be able to listen to us in that case. Like, yes, in addition to technology and soft skills, our students have a basic understanding of domain because they know the skill, they know the structure. Using that structure, they can be they can be more productive than their competitors. Now, it is not proven. The structure itself, nobody knows. I don't know how many industries will be listening to this piece of advice. But then, if they listen to it, if they know what we are talking about, they will certainly be positive about it. And again, your question is which industries we should approach, which IT companies we should approach, or industry we should approach. Any industry or any IT company, most of the workforce will be engaged in a particular industry, this or that. So that way, everyone is impacted. But then this whole thing is new. Nobody knows about it. Nobody has a background about it. That's the real thing.
Okay, thank you. Thank you. I will try for our student with the placement officer. Okay, thank you.
Yeah, and then once we say that this will be a differentiator, then let's say 2-3 companies came just because of this, that your students are now industry trained also in the way that we have discussed. Slowly and steadily, other industry fellows, other colleges will get attracted, and then that is where the journey will start.
Okay, 2 minutes quickly. I will tell more. I will not talk. Just 2 minutes.
Sure.
Now in VTU, in VTU, we are under Visraya Technological University. Final year student, they have to do the internship. So if your company will enroll under internship, that detail I will tell you. If you are interested, then our student can onboard your under your company. They can do the internship. So that detail I will talk to you. Just one suggestion from my side.
Yes, we have respect to that. Yeah, but get us started. Right. Thank you for this.
Thank you. Thank you.
Thank you, ma'am. Sunita, ma'am.
Yes, ma.
Over to you.
Good evening to everyone present here. It is my honor and privilege to deliver the vote of thanks for session 10 of our AICTE ATAL Academy sponsored 6-day online faculty development program on next-gen management, applications of artificial intelligence, and data analytics in business strategy. First and foremost, I extend our deepest gratitude to our esteemed speaker, Mr. Manoj Kumar Lal, innovator and insurance domain consultant at TCS, for delivering a highly insightful and intellectually stimulating session titled Trends of AIML in the Industry, Structuring Knowledge Across Industry, Enterprise, and Project. Sir, your session truly transformed the way we perceive knowledge management. Your explanation of knowledge driven development KDD from the challenges of scattered, unstructured knowledge to the power of structured, hierarchical knowledge was extremely enriching. The visual demonstration of how KDD helps was highly valuable for all the faculty members. Your practical examples, industry observations, and the clarity with which you presented concepts such as enterprise knowledge reuse, hierarchical knowledge structuring, and the academic applicability of KDD made this session truly exceptional. We are grateful for the time, effort, and depth of expertise you shared with us today. Our sincere thanks to our chairman, Dr. SNVL Narasimharaju Garu, for his visionary leadership and constant encouragement, which make programs like these possible. We extend our deep gratitude to our principal, Dr. Rakesh SG, for his continuous support, motivation, and guidance throughout this FDP. A special thanks to our Dr. M. Kadiravan, HOD MBA, whose meticulous planning and coordination ensured the smooth conduct of today's sessions. Finally, a warm thanks to all the participants. Your presence and involvement added great value to the session. Thank you all. Have a wonderful evening.